covering transformation in this topic. Transformation matrices are already uploaded. So let's see. In transformation, you have 4 topics. One is reflection, second is rotation, third is enlargement, and fourth is translation. Okay, coming on the first topic, let's talk about reflection. Okay, now consider this grid. We'll be discussing 4 types of reflections: x-axis, y-axis. For example, you have an object and you are asked to reflect it in y-axis, or the examiner may say x is equals to 0. So you can see where the y-axis is. So it should be 2 units away to left as it is 2 units to right. So you reflect all the 3 points and draw the triangle. So this is the reflection in y-axis. If you are asked to draw the reflection in x-axis, consider this triangle. I'm naming it A. This is x-axis, this is y-axis, and you just count the distance. So we just count the distance and we draw the triangle. This is 1 unit up, 1 unit down, 1 unit up, 1 unit down. This was 3 units away from x-axis, this is 3 units away from x-axis. So this is the reflection in x-axis. For reflection in y equals to x, the coordinates will always swap. It is way easier when you have a labeled grid. For example, your triangle is this, and let me label them as 1, 2, 3, 1, 2, 3, 4, 5, and 6. So I know this coordinate is 1, 4. 1, 4 would swap to 4, 1. So this is x4, y1. The other way is you can see the perpendicular distance between the point and the mirror line or line of reflection. So it comes here. If you see, this is 1 block diagonally, this should appear here. And just to compare, the coordinates of this point was x2, y4. So x2, y4 should swap to 4, 2. see for yourself, this is 4, 2. And the third point is 1, 2, 2.5 boxes, so half, 1 and 2. This is a reflection in y is equals to x. Easiest method is just swap the coordinates. Now you may have different lines, the concept stays the same, and this is how you will solve for reflection. For example, we are given with this line x is equals to 4. Consider them 1 unit each. 1 box, 1 unit each. And you have a triangle which lies here, and you're asked to reflect the triangle in the line y is equals to 4. So count this is 2 boxes, so move 2 boxes to right. Now for this unit it is 3 boxes, so 3 boxes to right. For the last one, this is 3 boxes, so 3 boxes to right. So it is reflection in x is equals to 4. On this same diagram, if we have a line y is equals to -1 and you are asked to reflect triangle A, so these are 3 units away, so 1, 2 and 3 units away from the line of reflection. This is again 3 units away, so 3 units below the line of reflection. Last point is 1, 2, 3, 4, 5 units above, so 5 units below the line of reflection. This is a reflection of triangle A in the line y is equals to -1. The verse of every question is part of your syllabus. You are asked to draw the image of the given object in the line of reflection. So you may have object and image. We are discussing three things here. One is the object, second is the image, and third is the line of the reflection. So two of these should be given. First we considered object was given, line was given, and image was unknown. Now let's see if we have the object, if we already have the image, and how will we find the line of reflection. So for example, this is given, and line of reflection must lie exactly between the two corresponding points. So these 2 points are corresponding to each other, 1 2 3 4. They are 4 boxes apart. So draw the line in between them, and we can count on the grid whatever the value of x is here. So this is how you would solve for reflection. Now next case is rotation. Rotation has 3 type of cases, that is 90 degrees clockwise, 90 degrees anti-clockwise, and 180 degrees. It's not to mention. There are few questions which may consider 270 degrees. If you know you are moving 90 degrees clockwise, that is exactly equal to 270 degrees anti-clockwise. 270 degrees anti-clockwise or 90 clockwise is the same thing. For 90 anti-clockwise, if you are moving 90 anti-clockwise, which is actually equal to 270 degrees clockwise, and 180 stays 180 on both sides. So if you are moving clockwise or anti-clockwise, it reaches the same point, so that's not an issue. So let's start with 90 degrees clockwise. You are given with the grid which is fully labeled, and you have an object resting here on the plane, and you are asked to rotate it 90 degree clockwise about the origin or about the center. Center rotation will always be there in a case when you have to draw the rotation. Reverse is also possible. So for example, this is the point. Now consider it that you have to rotate these 3 points 90 degree about the center. So I'm going to draw a line which is 90 degrees and clockwise coming on this side, and at 90 degree this is the point where it would make 90 degrees. I can see through the boxes, it is a diagonal, and this is 45 and 45 degrees. This is one way. So 2 boxes away, 2 boxes away, this is the first point. And second is, if you see through this, this is one way. You can place your protector and see where it lands. So I have this first line, and third is this one. So this should pass from the given points, and this is 90 degree clockwise rotation. This was one way, that you draw the line and then see where it would pass, where it would make an angle of 90 degrees. And this is 2 units away, this should be 2 units away. This is 3 units away, this should be 3 units away. The other way is count the boxes and do not use protector or compass. So I'm drawing this same triangle. Now see, imagine if you have to rotate this, let me label them for ease of speaking. If you have to rotate coordinate A 90 degrees, I can see that this is 2 units horizontal and 2 units vertical. So when you rotate it clockwise, what happens? This horizontal line will actually be vertical, and this vertical line is following this line, and I know A dash would lie exactly at this point. Now I'm erasing this to avoid any confusion. Look at point B. If I count this, this is 3 2. 3 units to right and 2 units upwards. So when this point right here is going to move clockwise, this is horizontal, it would be a vertical line 3 units downwards and 2 units horizontal. This is point B. For the third point C, this is 2 units horizontal and 4 units upwards. So this horizontal line is going to be vertical now, 2 units down and 4 units here. Just count it. So you can compare both of these shapes, take a screenshot or pause the video. You can see that they exactly lie in the same position. So having said that, just give it a shot, practice on 2 to 3 times and you'll be good to go. Now see, without drawing the lines, I can see this is 2, 2. So I'm counting 2, 2, first point. Now for this second point, 3, 2 is 3, 2. For this third point, 2, 4. So this is 2, 4. That's it. You've done the rotation. Now do not forget to draw these construction lines to tell the examiner how you actually went through them. So this is 90 degrees clockwise rotation about the origin 0, 0. Now let's try when it is not the origin. Standard stays the same, procedure stays the same. If you have this triangle right here, an examiner asks you to rotate it through this point, x1, y minus 1. Now just see, this is 1, 2. This horizontal one will go vertical now. So 1, 2, first point done. Second point, 2, 2. Follow this cursor, 2, 2. So 2, 2, second point done. Third point is 1, 1, 2, 3, 4. So 1, 1, 2, 3, 4. This is 90 degrees clockwise rotation. 90 degrees clockwise rotation about this given point, x1, y minus 1. Same case would be for anti-clockwise. I'll do it for you. And then 180, and we'll jump on that object is given, center is given, and we are drawing the image. An object and image would be given and we'll be finding the center. Now 90 degrees anti-clockwise. I'll skip few parts and solve it directly as the process is same which we just covered. So consider this triangle and let's say we rotate it about the origin. So this is 2, 2. Now anti-clockwise, moving towards left hand side, 2, 2, 1, 2, 3, 2, 3, 2, 2, 4, 2, 4. So you've rotated this triangle 90 degrees anti-clockwise about the origin, and these are the corresponding points. 90 degrees anti-clockwise about the origin. For 180 it is very easy. Triangle is given, center of rotation is the origin. 180 degree would actually make a straight line, so you can just go exactly beyond this point. This is 2 units, so 2 units, and you see, draw this dotted line here. It is easier when you draw it on paper. So this is 4 boxes and diagonal away, 4 boxes and diagonal away is this. Third point, place your ruler which passes through the origin and this point and stretch it the other way around, you get the third point. This is 180 degree rotation about the origin. Now we were given with the object, we were given with the angle of rotation, we were given with the center, and we do the image. These 3 points were given. Now if we switch between this, object is given, image is given, and you are asked to find the center of rotation and sometimes the angle as well. So the angles are 90, 270, 180. The statement would make clear that what you have to answer. Mostly it is 90 and 180. So for example, you are given with this object and image. Now you have to foresee it if it looks like it is 90 degrees or 180. So if you just join the corresponding lines, this is a cornered 90-degree point. I'm joining these corresponding lines, and then these two corresponding lines, they pass over each other, they overlap at this point. So it is 180-degree rotation, and the center of rotation is 1 2 3 4 x4 y1. So center of rotation for this case was 4 comma 1. In 180 you just join the corresponding points and they overlap, the cross at the center of rotation. For 90 degrees there is one extra step. For example, we have these two triangles, and they look like this. Now join the corresponding two points. Let me change this a bit to differentiate between three sides. If I label them A, B and C, 90 degree would be A dash. B, look at this, this is 4 units, this is 3 units. So this should be B dash and this is C dash. For 90 degrees, what you need to do is join the two corresponding points and draw the perpendicular bisector. So drawing the perpendicular bisector, place your needle at A, draw the arc on both sides, then on A dash draw the arc on both sides. So this is the perpendicular bisector. Then join another point. Let's say I select C and C dash and repeat the same process for it. Draw the perpendicular bisector. Where the two perpendicular bisectors will meet, that will be the point of rotation, center of rotation. And C point rotates from this point and comes over this point, and this is your angle of rotation. This was all about rotation. Third point is enlargement. Okay. Now we have two types of enlargements. One is positive, the other is negative. We have scale factor, how much the image would be enlarged. So object, scale factor, center of enlargement, and the image. Object would be given, scale factor would be given, we have to see it is positive or negative. Center of enlargement would be given, and you'll be able to draw the image. A quick comparison between them. This is the center, this is the object. If you are increasing the size on this given side, this is positive, whatever the scale factor will be. If this is the center, this is the object, and you move in the reverse direction, the opposite direction, and you draw the object, this is negative enlargement. So this is the only difference between positive and negative. Scale factor, object, image, everything else is same. Let's try and draw a neat question. For example, you are given with this object and center of enlargement is origin 0, 0, and scale factor is 3. So we can see this is positive 3. Join every point with this and extend the line. It is very easy with compass and on paper. So join every line and extend it. It should look like this. When a scale factor of 3 is given, so you see this is first length, second length, third length. You can draw this by counting, or you can draw this using compass. Then this is 1 box, 2 box, 3 box. Scale factor was 3, so we are doing it 3 times. If it would have been 2, I'll stop right here. And for the third one is 1, 2 and 3. So connect the third point for everyone, the triangle is enlarged 3 times. So you can see this length is now 3 times longer. This length is now 3 times longer. This length is now 3 times longer. And you can also apply this formula, a1 by a2 equals l1 by l2 whole squared, similarity, and the ratio would be obviously 1:3. So we can rightly say their areas are in the ratio 1:9. So this is positive enlargement. Same case for negative enlargement. If you are given with this triangle and the examiner says take this as center of enlargement and scale factor is -2. Same process but in opposite direction. Connect every point and extend the line. Connect the second point and extend the line. Connect this third point and extend the line. Now scale factor is -2. We always count from the center. So this blue line is 1 unit, in opposite direction 1, 2. This green line is 2 units in diagonal. So I'm counting 2 times, 1 time, 2 time. Then this red line is 3 units, so count it 3 times. 1, 2. It should pass from this point. Saying that again, it would be easier on paper. So this is your final result, which is actually 2 times larger than the given object. Another thing, how you recognize between positive and negative scale factors when the object and image are given. If I label them A, this is A dash. If I label this as B, this is B dash. So the image stays upright. In this case, A falls down, B moves upwards, so it is rotated. So how would you find the center and scale factor? Is object and image are already there. So reverse of whatever we did, join them, and this is your center of enlargement. And what is the scale factor? You can count this. This is 1, this is 3. Scale factor is +3. For negative, this would be an inverted shape. Connect the corresponding lines. So wherever it passes, this is your center of enlargement, and you can count from any point. If this is 1 unit and this is 3 units, so you can say -3. If this is 1 and this is 4, you can say -4. That is all about enlargement. Fourth one is translation. After this, we'll practice few questions from past papers. Translation is basically vector. So translation of vector. If you have this object A, then you're given a translation vector 2, 3. So you have to move every point 2 units in x-axis and 3 units in y-axis. So this point 2 units and 1, 2, 3. Second point 2 units and 1, 2, 3. Third point 1, 2, 1, 2, 3. So this is translated by 2, 3. If it would have been -2 and -3, so 2 units to left and 3 units downwards. 2 unit to left, 1, 2, 3 units downwards. 2 unit to left and 3 units downwards. So this is translation. Object was given, translation vector was given, image was unknown. So you may have an object and image. An examiner may ask you about the translation vectors. So I'm going to count. This is 1, 2, 3, 4, 5, 6. 6 units to right and 2 units upwards. So it is a translation vector of 6 2. It is a translation of 6 2. If it is from A to B, if it would have been from B to A, it would be -6 and -2. So -6, -2. Now let's move on to some questions from past papers. Let's try these questions. These are scanned copies of red spot. The diagram below shows three triangles P, Q, and R. So P, Q, and this is R. Triangle T is the image of triangle P under an enlargement. Center is 5, 2. So this is x5, y2. This is the center of enlargement, and we have to enlarge P with the scale factor of 2. Now remember what we did in notes. We will connect each line, and as I told you, it is very easy on paper. So connect these lines and extend it. Then connect these two and extend it. Place your scale at the center, this point, and extend it. So we know the scale factor is 2 from this center. This is 1, this is 2. From this center, this is 1, this is 2. From this center, 1 and 2. So we can draw this triangle and label the new triangle as T. Next part says describe fully the single transformation which maps P onto Q. Now observe P onto Q. It is not dragging, so it is not translation. The shape is not increasing in size or decreasing, so this is not enlargement. So it is definitely rotation. It is also not reflection, as it is not the image, inverted image. So it is rotation, which I can see it is 90 degrees clockwise rotation. But how you will solve it, you have to find the center of rotation first. So join the two corresponding points just for the ease to speak. If this is A, B, and C, we can say this is A dash, this is B dash, and C dash. So join two corresponding points. If I join B with B dash, draw the perpendicular bisector. 1 2 3 4, 1 2 3 4. In this case, this is a perfect horizontal line. So perfect vertical line between these 2 points could be drawn. So this is the perpendicular bisectors for B and B dash. Now join other 2 points, any 2 points. I'm selecting A and A dash. You may choose C, C dash. Now draw the perpendicular bisector for this line as well. So draw the arcs and draw the line. So where these two perpendicular bisectors meet, that is the point, that is the center of enlargement, the center of rotation. So describe fully the single transformation. So we say it is a rotation of 90 degrees anti-clockwise about 0, 0, about origin or about 0, 0. Find the matrix representing the transformation which maps Q onto R. So see, Q onto R is actually a reflection in line y equals x is equals to 0 or y is equals to 0 or x-axis. So reflection in x-axis, I've uploaded a different video before this one. So this is 1, 0, this is 0, 1. So when it will be reflected, the final answer would be this stays here, the point comes down and becomes x 0, y minus 1. So what happens to x-axis? It stays 1, 0. What happened to the point on y-axis? This became 0, minus 1. So this is the matrix of reflection in x-axis, or y is equals to 0. The diagram below shows triangle A and triangle B. So we can see A and B. Describe fully the single transformation. So A and B are reflection of each other, and you see these corresponding points. These are 3 boxes apart. So draw the line between them, which is, it is a reflection in line y is equals to -1/2. Triangle A is mapped onto triangle C by rotation. Center is origin through 90 degrees anti-clockwise. Okay, we can see A and center is the origin 90 degrees anti-clockwise. So we're moving to left. So this point when moved to left by 90 degrees would appear here. Second point would appear on this. And third one, this point right here is actually 2 units to right and 1 unit upward. So it will be 1 unit upward and 2 units left. So this is your resulting triangle from A to C by 90 degrees anti-clockwise rotation about the origin. Write down the metrics that represent this information. So straight away again draw that 1, 0. This is x0, y1. So what happens when you rotate it 90 degrees anti-clockwise? This point would become x minus 1, y0, and this lands here, which becomes 0, 1. So what happens to the point on x-axis? It became 0, 1. What happened to the point which was on y-axis? It became x minus 1, y0. So this is a matrix of 90 degrees anti-clockwise rotation about the origin. I'm skipping this question. This is not no more in your syllabus. That is stretch. Okay, the diagram right here shows. I write down the vector representing the translation. So translation which maps A onto B. It is coming from A to B. So we select these 2 points. Always count x first. So this is positive 2. And downwards it is 1, 2, 3, 4. So minus 4. And you get your vector 2, minus 4. Triangle C is an enlargement of triangle A with center 5, 3. Let's see what we've covered before we solve that. We've done reflection, rotation, enlargement, translation. So syllabus is already covered. We'll upload more questions soon. Let's finish this first. The triangle C is an enlargement of triangle A. Center is 5, 3. So x5 and y3. And we have to enlarge A with the scale factor of 3 and label this C. Now all you have to do is pick up your scale and pencil and draw the lines and extend them. So join this line and extend it. Then join second line and extend it. Then we join it with third line and we extend it, and our scale factor was 3. So always count from the center, from this point to this is first, second, third. So I found my point. Then this is first, this is second, this is third. So you found your third, and this is 1, 2 and 3. So draw the triangle C and label it. The diagram shows ABC's triangle is translated by 9 2. 9 units in x-axis and 2 units in y-axis onto A dash, B dash, C dash. Find the coordinates of C dash. So we already have C. So 2, 1, and we add the translation vector to it. So C dash would be 11, 3. What is the special quadrilateral B, C, C dash, B dash? So if you see this is B and C, B would go to B dash and C would go to C dash. And don't forget these are parallel. And BC is equal to B dash, C dash. So the special name given is parallelogram. Find the area of quadrilateral B, C dash, B dash. I'll skip this part for now. That's mensuration. Question number 6. The diagram shows triangle A. So we can see this triangle here. The translation minus 4, 3 maps A onto C. On the diagram, draw and label C. So this is minus 4, 3. Count every point. 1, 2, 3, 4, minus 4 and 1, 2, 3. So I have the first point. You don't have to actually count them literally. You can also just draw them by just looking at triangle A. Every point has been moved minus 4, 3. B bar says the rotation 90 degrees clockwise about 1, 1. So this is 1, 1, which is 90 degrees clockwise, and we have to draw triangle D. So 90 degree clockwise, consider this that you've connected it. When it moves 90 degree clockwise, the point lands here. Second, this point is 2, 1, so it would be 2, 1, this lands here. Third point is 4 units to right, so it becomes 4 units downwards, and your final answer is 90 degrees clockwise rotated about 1, 1. This is 0. Thank you so much. Take care. Allah Hafiz.